Okay, so you've probably seen some courses on what ESR is, what DCR is, the difference between capacitance and that sort of thing. And now you want to know, well, how does the cap analyzer actually check capacitors in circuit when you know a capacitor tester can't? Because you can't measure capacitance in circuit, you can only measure ESR and DCR. Okay, well, here's the cap analyzer, which has two different test modes. The main test mode, simply by turning it on, is where it tests a capacitor completely. It'll discharge it first. It'll check the DC resistance of the capacitor, DCR, from 0 up to 500 ohms. You can preset it wherever you want to be warned at. And then if it passes that test, then it checks the ESR and gives you the reading here. So in testing, here's how we use it. We've turned it on. It's on the standard mode. Since we are going to be checking DCR first, we will set this to a reading that we want to be warned at. Most technicians really want to know if there's an absolute short in the circuit. I tend to be a little more careful. I'll usually set my cap analyzer at 200 ohms. And what that means is that if there's normal resistance in the circuit of over 200 ohms, it'll ignore it, and that's fine. But if I have some leakage in the circuit and it's under 200 ohms, I want to know about it. So for example, if I shorted the test leads together, very obviously, DCR would be low because that's under 200 ohms. So if we're going to check capacitors on a board, and here's a board from a video monitor, just as a point of interest, luckily this board only has 3 value capacitors on it, so it makes it easy to compare. The real small ones are 10 microfarads, the medium-sized ones are 100 microfarads, and the large ones, there's only 3 of them, are 470 microfarads. So what we want to do is know what the value is of the capacitor first of all, so that we can look on the chart. So for example, if we were going to measure this 100 microfarad capacitor, we can see that the cap analyzer has columns here from 0.47 microfarad all the way up to 2.2 K microfarad, or 2200 microfarad if you prefer to call it that way. So the idea is know what value the capacitor is first so you know what column to look in, and it's like an XY thing. The X coordinate will be the value of the ESR. The Y coordinate would be the column for the capacitor that you're testing. So we're going to use, as an example, this 100 microfarad capacitor as a test. So this is the column for the 100 microfarad capacitor. And as you can see, the green areas are 0.1 and 0.25 ohms ESR. Anywhere from half an ohm up to an ohm and a quarter is kind of yellow, which just means it's a poor quality capacitor but still usable. Anything 1.5 ohms and higher is deep in the red. The ESR is too high. This capacitor will not work correctly at high frequencies. So here's how we test it. We're going to test this 100 microfarad capacitor. This one's easiest to test on the bottom of the board. When you put the test leads across a capacitor, it can be either polarity, it makes no difference. First thing, if you watch the cap analyzer, it'll discharge a capacitor, check the DCR, passes that test, and then gives us a DCR normal. And then if you look, you can see that the 1.00 ohm LED is on. So we follow the 1.00 ohm LED over to the 100 microfarad capacitor. You can see we're in the middle of the yellow. It's probably normal considering the quality of today's electronics. I would say that one is good, so I'm going to take my green magic marker, and just for my purposes I'm going to mark it green so that I can check all the capacitors on this board at one time in probably less than 5 minutes when I really get going. And when I'm done, there'll be a lot that'll mark green and there'll be a lot that'll mark yellow. Red, the ones that are marked red obviously are going to be the bad ones. So we've already checked this one. Here's another 100 microfarad capacitor. Let's test that one and see if we get the same reading that we did on the first one, which is an ohm or thereabouts. So we go and measure across that one. Oh, look at this. See the scale? It's on 8 ohms. Alright, so we're deep in the red here. Here's your 8 ohm scale. If you follow it over to the 100 microfarad capacitor, we're deep in the red. So I'm going to take my red magic marker. I'm going to mark this guy red. So now I got a red cap and I got a green cap. So when I go through this board later on, all I have to do is simply replace all the capacitors that are marked in red and leave the green ones alone. Let's continue checking on. Remember, we're still using the standard test mode where it discharges the capacitor, checks the DC resistance, and if it passes that test. So what the cap analyzer did was check the capacitor. What the cap analyzer did was discharge the capacitor first. Then it checked the DCR to let us know if it was under or over the 200 ohms. We know it was over that, so it didn't warn us. and then we got the reading. So now we're going to check some larger capacitors. These are 470 microfarad capacitors. So since we know they're 470, that's the scale here, you can see we need a pretty low ESR for this capacitor to really be good. 0.1 ohms would be ideal. That would be a brand new capacitor. Because the very next step is red, even if I were measuring 1/4 ohms, in most cases I would probably let the unit slide for that, even though we're in the red. And that's only because this chart was derived from charts that companies that make capacitors give us to say what the ESRs of brand new capacitors are. We know that the quality of the capacitors coming in modern day electronics aren't that great, and on top of that it's an older unit. You know, if it's aged a little bit, it may go down 1 or 2 LED digits, and I would probably live with that. What you wouldn't want is one we saw earlier where that 100 microfarad was measuring in the middle of the red. It clearly was very, very bad. So let's measure these 470 microfarads. Here's a few of them. So let's measure this one first. Okay, this one's measuring 1/2 ohm. As a 470 microfarad goes at 1/2 ohm, and here's your 470 column, we're in the second red. You know, I may replace it, I may not. Typically, in a case like this, where I knew the monitor had a problem and I already found the one capacitor that was really, really bad, more than likely I would let the other one slide because this one is probably the one causing the problem. Let's check the rest of these. Here's another 470 microfarad. It's also measuring 1/2 ohm. Consistent, so we're good so far. Here's another 470 microfarad. This one's even better. This one's like in perfect condition, 1/4 ohm. It's only on the very, very first red. I would probably leave all of those. It seems like on this one, the hundreds are suspicious. Let's check some of the very small ones. These are 10 microfarad. Let's see how they check. Now, on a 10 microfarad scale, you can see your reading could be pretty high and still be good. Green starts at 2 ohms. So we know anything less than 2 ohms on a 10 microfarad is fine. So let's just go ahead and measure some of these. Here's one. It's measuring 3 ohms, and we've already said that on a 10 ohm, anything better than 2 ohms is good. 3 ohms is in the middle yellow. I'd probably leave it. Let's measure another one. This one's measuring 3 ohms, so we're good for there. Here's another 10 microfarad. That one's really good. Let's continue on. Again, I've been marking them with green. You already know the procedure. Here's another 100 microfarad. That one's measuring 1 1/4 ohms, which on 100 microfarad is in the yellow, so I would leave it. So you understand the concept. What I'm doing is checking all the capacitors in this unit, and I'm checking for DCR first, and then after that I get an ESR reading. Now let's go on and say, well, we want to save a little bit of time. We know there's no shorts in the board because the monitor did come on. It just acted very erratic till it warmed up, so we knew we were looking at a capacitor that was dried up. I think we already found the culprit. So what I'm going to do is turn off the cap analyzer, and this time we're going to use the Insta-ESR function. Now what that does is that instead of the 3 steps, first one of discharging the capacitor, then secondly checking the DCR, and then third checking the ESR, what we're going to do is eliminate the first 2 tests. It speeds up testing a lot, saves on batteries as well, so we don't have to worry about spending the extra time. So the way you do that is you touch the test leads together, and as you're doing it you turn it on. Instead of the Star Trek theme going up and down, you'll hear a much simpler double beep system. A couple of quick beeps basically. So now it's going to measure them very quickly, and here's where your speed is. Watch how fast we can test them. Instant reading. Plus you've got the beeping too. As you probably heard, the number of beeps is for how good the quality of the capacitor is. Like on the, for example, the 470 microfarad, we were getting 1 beep. Good capacitor. On a bad capacitor, it's warning you 4 beeps. The cap analyzer beeps anywhere from 1 to 5 beeps depending on the scale. So half the time, you don't even have to look at it. You can just listen to it, and you know you're good. Here's a 470 again. 1 beep, 1/2 ohm, very, very fast. Just keep in mind that because you are not measuring DCR first and you're not discharging the capacitor first, that you're simply leaving those 2 parts of the test off. The discharging part may not be much of an issue. Most capacitors nowadays don't stay charged up. That was more of a thing from the television sets from the 1970s. But keep in mind that if you do have a short in the board, you won't know it if you have the Insta-ESR. So if you're suspicious at all, again, turn it off and turn it on without the test leads touching. And you can hear by the Star Trek beep that that is the full test, and now it will test the whole thing first. It'll discharge, check DCR, and DCR is normal. Now going on to what DCR is, we've had a lot of people call in and say, well, I'm not entirely sure what the set alert is, where do I adjust it? I have no idea where to adjust it, anywhere from 0 to 500. What does that mean? Very simply, what this does is simply measure, just like an ordinary ohm meter, it's simply measuring the resistance DC of the circuit before it checks the quality of the capacitor's ESR. Why do you want to know this? Well, maybe you've got a unit that came in that's not working and you have a shorted capacitor, or maybe something in the circuit is shorted. It may be this transistor here. You don't know. The idea of this is that you can be warned of a value under whatever you set it for. So for example, I know that most audio-video circuits, when I measure with an ohm meter across a capacitor, I usually get a few thousand ohms. You'll see the reading start low at maybe 500 ohms and then work its way up as the capacitor charges. So I know if I set up for 200 or 300 ohms, I'm probably okay, because this way if I do have a dead short, well, I'll certainly know about it because I'll hear that. So I've set the cap analyzer to warn me on anything under 300 ohms. So, for example, I have purposely rigged up a capacitor here with a short across it, but it's not a dead short. You can see the resistor in here. I think it's about a 100 ohm resistor. So if we were going to measure across this capacitor on a normal day and we say, okay, well, here's a 1,000 microfarad capacitor, oh, we're getting a warning. DCR is too low. We have a short. Well, it may be the capacitor, it may not. I'm interested to know what the value of the short is. Well, here's a quick and easy way of knowing. You could use an ohm meter, but here's my way of doing it. All I'm going to do is put the test leads across it, so I get my beeping, and then I'm going to lower the slide control till the beeping stops. And right at 100 ohms it stopped, so I know I have a 100 ohm short. So the whole idea is that if you do have a short, maybe it's the capacitor or maybe it's something in the circuit. The next step I would do would be to unssolder the capacitor and test it out of circuit. If it's shorted, it's obvious. If it's not shorted, then I know it's something in the circuit that's shorted, and then I'll whip out my leak seeker and actually trace the location of the short using the leak seeker. But in essence, that's how the cap analyzer is used. Hopefully that will explain to those who have used it and were a little confused about how to use the DCR set alert and what Insta ESR is. Maybe that'll give them an idea of how to use the cap analyzer. And you also heard the beeping, so you know the 1 to 5 beeps lets you know anywhere from good to bad. And if there's any questions, be feel to go to our website and go to our Tech Assist page. That'll help you out. Or give me a call. You have our number. And that concludes.